Hi, my name's Jeff, and I'm kind of an alien here. I'm not a ManageIQ developer or a user, really. That's totally why my shirt's green. I work for a company called the OpenNMS Group. We maintain a project called OpenNMS. Who here has heard of us and what we do? Yeah? Anybody actually used our stuff? Yeah? Okay, cool. So yeah, I've been a nerd since way back. I started doing Linux stuff and fell in love with open source software and the open source way of doing things back in the mid-90s. Started doing IP networking at NASA back in 1999. That's where I got introduced to network management and kind of fell in love with that as a discipline. A few years later, I was working at a big telco that wanted a scalable network management platform without a budget. And that's how I came to get involved with the OpenNMS project. So I came in via the community of users. And since then, I've been really down in the trenches doing nuts and bolts stuff, end user support, consulting, training, basically whatever I need to do. And it was giving a talk not dissimilar to this one at FOSDEM in January that I met Carol, and she invited me to come talk to you lovely people. So very pleased that that came to pass. I'm going to talk about network management. How many of you are into network management? How many of you are into network monitoring? How many of you are into systems monitoring? Okay, cool. So it's really all the same to me. I think we ought to call it networked management because we say we're a network management platform and people say, oh, well, I don't care about routers and switches. I'm a server person. I'm a firewall person. If it's on the network, it is a networked asset and we're concerned with its management. We think about the network as not just the plumbing that makes your bits move around, but all the stuff on it that makes your business go and really everything on the other side of your keyboard. Who knows what this means? Anybody recognize this? All right, FCAPS. FCAPS, fault, configuration, accounting, performance, and security. This is the ISO model for describing the capabilities of network management systems. A little bit of history about network management generally. The discipline really kind of goes back all the way into the mists of time in the 80s. So, put on your leg warmers. Anybody here use Sun products when Sun was still a thing? Yeah, anybody use Sun Net Manager? Oh. It is the product that invented the genre of network management. It spawned a whole slew of similar products. You've probably heard of ones like HP OpenView, Network Node Manager, which is now a part of a suite called HP Operations Manager. They keep changing the name, which is a brilliant tactic for keeping your competitors from learning anything about your portfolio. Just change the name every 3 or 4 years. IBM Tivoli NetView, which is now part of the Tivoli suite, which also now includes the former Micromuse NetCool products. So that's IBM's stuff. There's BMC Patrol that some of you might have bumped up against in your past. There's CA Spectrum, now it's under CA. eHealth, which was Concord. I actually worked on that product in the early 2000s. So there are lots of proprietary offerings in this field. And round about the late 90s, early 2000s, people started thinking, well, I like doing open source stuff, and I've got some servers that I need to make sure are up and running. So this generation of open source network management tools kind of came into existence. The first ones were very much point tools. Who's heard of Nagios? Yeah, everybody. All right, who hates it? Whose soul has it crushed? Yeah, exactly. It's a great thing for running a bunch of scripts on a periodic basis against a bunch of stuff on your network to make sure that it's doing what you expect it to do. Who's heard of MRTG, Cacti, these sorts of things that are really good at drawing pretty pictures of numeric data in a time series, right? So these are the early point tools that came about. Later on, some more comprehensive open source offerings did emerge. There was a thing called Hyperic that's later gotten hoovered up into VMware. There's an open core thing called Xenos that's still out there and some people like. I wish they'd actually make it open source, but at least they stopped crowing about it being open source since it's really not. And there are some newer proprietary offerings too. Everybody's heard of SolarWinds. Network people tend to love SolarWinds. They do a pretty good job. Sev1, I know some brilliant people from a previous life who work there now. So there's lots of software around there kicking about doing this stuff. But OpenNMS is unique because we were born at the same time as this first generation of open source point management tools, but we're a comprehensive suite. Our aim, it's not just an aim, it's a fact, is that we are the world's first enterprise-grade network management platform developed under the open source model. And that is our CEO, Taras Belog, talking 2 years ago or so at the Open Source Monitoring Conference in Nuremberg, and I could find 60 or 70 pictures of him saying the same thing with that same slide. So any opportunity that you get, if you see this man who's kind of in shadows there, he will be sure to tell you this. This is our sort of elevator pitch. Now, I was doing my research before this talk, and I wanted to know what Joe would look like so that I would recognize him. So I looked him up on YouTube, and I found him saying this, that ManageIQ is the first enterprise-grade open cloud management platform. That's pretty familiar sounding to me. And then I was sitting in the back of this room yesterday, and I heard Oleg say that they want to strike cloud from that, and that ManageIQ wants to be the open source management platform. Pretty cool. So it sounds like we've got some very, very similar goals. So let me tell you a little bit about our community, since yours is clearly very impressive. I'm really in awe of the community that you guys have built around this technology. And if I'm talking too fast, somebody throw something at me. I did push-ups first. So the community is made up, just in order of commit volume. The OpenNMS group, Inc., which is the commercial entity that I work for, makes up the bulk of the commits. There are fewer than 20 of us. I could do the count, but it just depends on how you count, what the number is. There's also a super secret core committers society that we call the Order of the Green Polo. The shirt's green, but it's not a green polo, green polo. There are 29 of those people. Some of you are probably wondering what's the amount of overlap between those. At the moment, it's 8. So we've got a pretty good representation of people from outside the company who are making commits. Also, as of a few years ago, we have an independent nonprofit foundation, the OpenNMS Foundation Europe e.V. It's a German nonprofit. And between the company and the foundation, we run 2 annual conferences every year. We have what we call our Dev Jam, the Developers Jamboree, every year in Minneapolis. The internet's fast, and we can sleep in the same building where we hack for a week, so everybody wins. And then we have the OpenNMS Users Conference Europe, which is typically held at the University of Applied Sciences in Fulda, a bustling metropolis. Or, as I've also heard it for anybody who's familiar with English geography, the Wolverhampton of Germany. A pretty cool city with some neat stuff to see, but just not a lot going on. But I love it. Yeah, so we've got people using this stuff. Like, these are logos of some companies that we know are using it. Some of these are customers, some of these are OEMs, some of these are not either of the above. They're just people we know from mailing list posts, discussion posts, to be actually using OpenNMS in anger. And so probably most of you will recognize at least 1 or 2 of these. And that gives evidence in support of the idea of our goal being to be the de facto network management platform, full stop. We want to be what you think of when you reach for something to do networked management, whether it's servers, routers, switches, whatever. We want to be the thing that comes to mind. Whether or not you're setting out deliberately to find an open source solution or not, we don't care. Kind of like Red Hat is with its portfolio of products. They just want to be the one that you think of They don't want you to think, I want an open source thing, so I'd better get Red Hat. They want you to think, I want a good thing, and that's what we want to be too. So to that end, we make a pair of promises. The first is OpenNMS will never suck, which is a bold promise to make about a piece of software, because all software sucks sometimes. But as a whole, we promise it'll never suck. And second, and more importantly, it will always be free and open source. There's not an enterprise edition of OpenNMS. It's not open core. It never will be. Backed up my slide. We do have 2 distributions of OpenNMS nowadays. For the longest time, since the very beginning, there was just one distribution of OpenNMS, and it was called OpenNMS. And it was GPL v2 licensed, then it was v3, then it was a Faro v3. But there was just one version. We had a stable and an unstable release at any given time. And we had this conundrum a few years back. We said, not enough people are using the unstable because the stable is so damn good. So how can we sort of drive people to the unstable? So what we did was we split the project into 2. We call the fast-moving Fedora-ish or ManageIQ-ish distribution, if you will, OpenNMS Horizon. And the idea is you're always chasing the horizon, but you never quite get there. That's where all of our fast-paced development happens, and we've made a slew of releases. We tend to release 3 or 4 times a year in the Horizon branch now. Meanwhile, we've got also Meridian, which is a customer access only, still Faro GPL v3 licensed product, much like Enterprise Linux. There's nothing in it that's not in Horizon. And if you want to get support for the product affordably, you get Meridian. And that's done a good job of letting us really step on the accelerator in Horizon while keeping our customers who value stability over new features very happy with Meridian. So functionally, how does OpenNMS stack up against the FCAPS model? We are primarily a fault and performance management platform. Each of these things is really hard. Every one of these 5 facets of network management is a difficult problem to tackle. We've chosen 2. There's a long history of products focusing on fault and performance, and a lot of products get only one of those 2 right. We think we've done a pretty good job getting both right. As far as configuration, accounting, and security goes, we tend to approach those, because they're such huge problem areas and our resources are limited, by integrating with other products that are out there that already do the job very well. Now, more stuff that I came to realize, and I'm about to throw up a slide here that may be incorrect. This is my own assessment based on just a little bit of time that I've spent with ManageIQ. But I find ManageIQ's capabilities to be strongest in the areas where OpenNMS is the weakest. Configuration management, yeah, you guys are rocking that. Accounting management, you're very, very billing focused as far as I can tell. And security management, you're hitting that pretty hard with policy enforcement and that sort of thing. But in terms of fault and performance, I'm not seeing a heavy focus there, and that's not a diss, that's just what I'm seeing. If I'm wrong about that, please, let's talk about it over a beer, because I want to know. But I have this hypothesis that our projects could do cool stuff together. And they kind of stack up pretty well. There's more than just what I've put in this little chart right here to back that up. We both use Postgres as our relational database. It goes on and on from there. I think there's a lot of complementary qualities of the 2 platforms. But what does OpenNMS actually do? Since very few of you have actually used it, I thought I would go into a little bit of detail about this. Functional rundown-wise, the first area that's the most important to get right, that's not actually correlated to one of those 5 FCAPS buckets, but I'm sure that ManageIQ people know it very well, is the notion of provisioning or inventory. And that's the very hard, dirty work of getting nodes and associated entities into and out of your inventory. OpenNMS has actually had 2 different service daemons over its history that concern themselves with this work. The first one was called CapsD. The new one is called ProvisionD. CapsD has been buried 6 feet in the ground for a while now, and sometimes we're nostalgic about it, but we're very happy with ProvisionD overall because it is much more flexible. It has an API, and it's got a notion of lifecycle management. The API works in both push mode via REST and pull mode, where you say, hey, ProvisionD, here's some URLs, and I want you to fetch a document from them periodically that describes a piece of your inventory, and it will grab those and synchronize them in a two-phased commit and turn whatever you've given it into its actual inventory that it's actually managing. The second big functional area that we work on is fault management. We are pervasively multi-protocol in this area. We sometimes call it service assurance polling. A lot of products use the term polling in a generic sense to talk about both availability and performance data, time series data. We mean, when we say polling, specifically availability. So is this thing responding to a ping? Is this web server responding to an HTTP GET? Is this SSH server responding with a banner that contains the letters SSH when we connect on port 22? It can go all the way from a very simple thing like a ping through a multi-step web transaction that involves logging into a form, making sure that you have a valid non-negative account balance, and logging out again and making sure that all of that stuff happens within 2 seconds if that's the constraint you want to put on it. So fault management and service assurance polling, all about up, down, and is it responsive enough? We can also optionally save the latency data that we pick up as a side effect of doing these tests, and we can visualize and threshold on that. Another related but separate in our model area is performance management. Again, here we are multi-protocol, we're pluggable, we support a whole bunch of different protocols for doing this, and it's the concern of metric data collection, time series numeric data about questions like how many IOPS has this disk serviced? How full is this file system? How many users are logged in? What's the exhaust temperature of the outlet in slot number 2 of this modular chassis? Those sorts of things. We do inline thresholding with that. So you can say, for instance, just pulling an example from my recent past, we had a provider that operates a Metro Ethernet network, and they were interested in correlating the optical power levels on some of their Metro E switches with the temperatures in the data center. So we set up thresholds for that say if there's a correlation building, then we can create an event about it. You can also report on these metrics that we gather via what we call the measurements REST service. So this is another point that we expose via the REST API. All of this time series data is exposed in that way, and if anybody here has ever used Grafana, in addition to our own built-in graphing code, we also created a Grafana data source plugin that uses the OpenNMS measurements REST API endpoint. So just a few of the protocols that we support are listed here. In addition to all of that, and really tying the whole system together, this is really the glue that makes the platform go. We have event management as a strong core concept. ManageIQ seems to be a very event-driven and oriented platform as well, so I probably don't have to go on at length about this. But everything that happens in OpenNMS, if it seems magical, it's not magic, it's events. We have an event bus that is at the core of the product. It was actually built in-house, and it's served us remarkably well considering its age. We're kind of in the process of looking at replacing it with a more distributable service bus, something like ActiveMQ, but it has served us from the beginning, and it served us remarkably well. In addition to internally generated events, like a service went down or a threshold was blown for some piece of metric data that you're collecting, we also have the notion of taking in events from outside the system. So we can take in, probably the best understood and known example is SNMP traps, but we can also eat syslog messages and scrape those with a regex and turn them into messages, and into events internally. And all of these events, regardless of their sources, are on an equal footing. They're directly comparable to each other. You can also create events via an XML TCP interface or by doing a post to another REST endpoint. And those events are also directly comparable to ones that started their life as a syslog message or a trap. We can deduplicate these events, so you don't have to be drowning in a sea of critical stuff. If you've got a noisy thing that's constantly spamming you with events, you can configure a reduction key for that thing and say, hey, only tell me once about this thing, but keep a count, keep a tally of how many times this thing has happened. And when we deduplicate those things, we call the result an alarm. Alarms are kind of events that matter. Alarms, unlike events, have a life cycle, so you can do things like clear them. They can actually be self-clearing for the kinds of things that have a self-clearing nature. An operator can manually clear things that can't self-clear, and that's pretty sweet. We can integrate with other external things like help desk systems as well, using using alarms as the integration point. We can also suck events into an embedded instance of the JBoss Drools expert platform. Who here has used Drools? Yeah, that's good, solid Red Hat technology. Pretty advanced stuff, but very, very powerful. And then finally, probably one of the things that people most frequently do with events is configuring notifications for them. Notifications are a mechanism for telling something, usually a human being, outside the system about a thing that happened in the system. And we can send those notifications via email or Jabber, or most recently we implemented an integration with Slack-compatible things. So your Mattermost chat can now have your OpenNMS notifications show up in a room. We've also got Topology. Pluggable providers for Topology. At the moment, they're all based on using SNMP as their transport for gathering data, but there's no reason we couldn't use other protocols for that. The routing protocols that we discover at the moment with this enhanced linkd daemon, as we call it, are LLDP, CDP, OSPF, and ISIS. I think there may be some others in there too, but that's not an area that I'm up to the moment about. And finally, we have the Web UI and REST API, which are very important for integration purposes. We overhauled both of these in 2015. We pulled in Bootstrap, Angular, and also overhauled our REST API to start using CXF instead of Jersey. Nothing against Jersey. It's my first time here, and I'm finding it lovely. Laugh. Thank you. So there's the architecture slide as required by law. Kind of the arrow, I don't know what the arrow means, but we've got our persistence layer, our app layer, and our web layer. We use Hibernate as our ORM. We have been using Spring. We're moving more in the direction of Carafe and OSGI for our dependency management. I know people have opinions about OSGI. I certainly do. Yep, Event-D moving towards ActiveMQ, and I'll talk about some of these components in more detail in the following slides. Historically, our architecture has been very centralized. We used to store all of our performance data and our response time data in RRD tool files. Anybody used those before? Yeah, so pretty good. It's pretty okay, but it has its limitations. Chief among them being, I didn't realize this for a long time, but RRD tool is read optimized, which is dumb because almost everybody's use case for RRD tool is write mostly. So yeah, that's where we came from. At the time, it meant we didn't have to build something of our own. Operations have always been centralized, although you could kind of build a quasi-cluster just by knowing enough about the architecture to pull it apart into several JVMs on different servers and allocate parts of the workload manually across a set of servers. So you could scale out a little bit if you were good enough at understanding these things. I've made Heiko choke by talking about OSGI, I'm afraid. Sorry. And historically, we've not really been cloud aware or controller aware. Same thing, really, if you think of a cloud as just a controller. Where we're headed with our architecture, storing time series performance data, we built a thing called newts. We stick the data into Cassandra, which is actually well suited. It's actually right optimized. I know we're not the only people to be building a Cassandra-based time series data store, but we hired a guy who used to work at Rackspace and is a Cassandra core committer, Eric Evans, to help us build the thing. And we've actually started fielding it and are starting to see some pretty cool results. It scales out much, much better, and the niftiest thing is when you start running up against a bottleneck in terms of your ability to store metrics, just rack in another Cassandra node and you've just scaled out some more. So that's pretty neat. We're also building a new architecture called Minion. The name actually predates the adorable little yellow guys, but we love bananas too. It may stand for Mini OpenNMS. There's probably a mailing list post where it was christened. And that's a fully distributed mode of operation where you can say, hey, okay, I want to stand up a new OpenNMS, but I want it to do just data collection. Or I want to stand up one in a data center that's inconveniently located on a slow link and just have it trickle in the data that it collects as its link allows. Or I just want that one to receive syslog messages, or I just want that one to be concerned with provisioning. So as much or as little of the architecture as you want in any given outpost, if you want, you can do that using Minion. OSGI with Carafe, we're using that not only for making modularity in support of Minion, but also just for pluggability in the core of the product. So even if you're not using Minion at all, you're still going to benefit from OSGI. Other things we've started fielding in the recent past include Kafka and Spark streaming, so moving our performance data around on a service bus and doing big data style analytics on this stuff. Very, very powerful. That's very new as well. And another thing that's just starting to happen is we're gaining an increasingly abstract notion of controllers, so things like SDN controllers, cloud APIs, vSphere, overt, what have you. Having those things actually modeled as controllers, and this extends to things like controller-based wireless AP systems as well. So, enough about OpenNMS. How can we make it work with ManageIQ? Well, I started thinking about this in January, and then I got the note that my talk proposal had been accepted, and I said, oh crap. And then my life became eventful a little bit more, so I looked at my calendar reminders and I said, oh crap. And I thought, well, how can I approach this most expediently? And I thought, okay, let's do something I've done before with 100 other platforms, and that's an inventory-based integration. So the idea here is let's have ManageIQ drive the OpenNMS requisitions REST API so that when you provision a new VM into ManageIQ, it gets provisioned into OpenNMS and magically appears. When you have a node get retired in ManageIQ and it disappears from the ManageIQ inventory, it should magically disappear in a puff of smoke instead of having alarm bells going off because we're monitoring something that was taken off the line yesterday. Once these VMs and instances are in OpenNMS, you get your fault and performance management capabilities that OpenNMS gives you, all for free. And this should be something that we can do today. I even took a swing at making it. So pretty simple concept. The idea, we have a notion of a foreign source or a requisition, which is it's literally an XML document that describes a set of nodes, interfaces, and services. So you have a foreign source, which would be something like, oh, I don't know, one per external management controller in ManageIQ's model terminology. And then you got a foreign ID, which is just the identifier within that external management system in ManageIQ for the instance or the VM. So looking at like EC2 US East 1 as your foreign source, you would have foreign IDs within that requisition that look like I dash some digits because that's what EC2 machine IDs look like. For the case of an OpenStack, we would use a foreign source of whatever you called the provider there, And the foreign IDs would be UUIDs because that's how OpenStack rolls. When we provision a new VM in ManageIQ, we would do a put into OpenNMS, and the node appears. When we delete it from ManageIQ, we do a delete into OpenNMS, and the node disappears. And this is a very common pattern, so I'm like, yeah, this will be easy. I got this. So I installed the Darga RC1 virtual machine and started building a custom automate method. And this ought to be real simple stuff. I figured out what's in EVM root for a provision thing and used the builder, the XML builder pattern, since we respond best to in OpenNMS to XML, although we can eat JSON too. But I thought, well, let's keep it simple and just build an XML document. So there's our foreign source and foreign ID. We're going to build an XML document. Here's the foreign ID. Here's the node label. For each of those, add an IP address for each IP interface. I'm not going to deal with SNMP yet, so let's say that there's no SNMP capability on that interface. And then let's put that right into the appropriate URL in the OpenNMS requisitions REST service. Cool. Here's the delete one. Even easier because we don't have to worry about what the node label is. All we need to know is the foreign source and foreign ID. And we do REST client.delete instead of REST client.put. And that should work. And then we just apply it via a control policy. And should just work, right? And I should have a really neat video demo like all the ones that I've seen today and yesterday. But then I actually let her rip the first time, and nothing happened. And then I let her rip again, and nothing happened. And I came to realize that I'm like this guy. I don't understand how your automate stuff works. It's not you, it's me. I just haven't taken the time to figure out. I think it's something to do with instances, maybe? I don't know. So yeah, I don't have a nice demo for you, but I know it's just a disconnect inside these two ears. So we'll get it working, and once it works, there are some pretty cool future possibilities for it, like syncing tags across the two platforms, and also automagically doing things in the nodes that we provision in OpenNMS according to ManageIQ tags. So for instance, if you have a tag that means to you, this is a web server, then let's go ahead and stick an HTTP service on the interface when we stick it into OpenNMS. Those sorts of things. Going beyond provisioning, I like to think that fault and performance would be sort of a new cross-cutting concern for ManageIQ. So maybe we providerize the notion of fault and performance, create an FPM provider notion within the ManageIQ model. And with that, you could do cool things like automatically adjust the billing if you're a cloud provider and you're not meeting your SLA for uptime on your customers' instances. Lots of other touch points. This would read on things like reporting and planning, alerting, and all those other sorts of things. Another area for growth that I think is true for both of our platforms is SDN. Right? I've filled a lot of rooms just giving an SDN talk that was almost pure speculation. So people are very hungry for anything about SDN. I can say that for sure. We've been working upstream a little bit in Open Daylight. I gave a talk at the Open Networking Summit back in March in Santa Clara, and that was well received. We've built a prototype topology provider. It turns out Open Daylight's topology is trivially easy to interact with, at least for the underlay. We're not sure yet how they represent the overlay, and that's just a staffing constraint, really, resource constraint from our perspective since we're a small organization. But once we have the underlay overlay, we've actually got another project within OpenNMS that's completely unrelated but dovetails nicely with Open Daylight topology called Project Atlas. That introduces the notion of layers to our topology model. So we'll be able to say, okay, for this element in the underlay, the following overlay elements map onto it, and if this particular OpenFlow switch disconnects from the controller, then we can do an impact analysis and say, okay, this overlay endpoint is potentially affected, that sort of thing. Also, other work we've done upstream, this one really just amounts to politicking on the Open Daylight daily calls. And that's, we've convinced the Open Daylight core team that it's a good idea to have separate strategies for storing time series numeric data versus time series or time-stamped string data. And with that change in the Boron release, it'll be possible to forklift in our newts persistence engine in place of the TSDR engine, which has kind of just grown up in place within Open Daylight. We're very much looking for partners in this area because it's going to take a lot of resources, and we don't have a lot of resources at the moment. So we've been talking with some players in this space and trying to marshal resources to make this happen, because we want to be the platform that understands your SDN comprehensively, not through some adapter that makes it fit the traditional model that you can do with just any old SNMP management system. So yeah, I've got some eye candy for you. This is ODL stuff. This is an Open Daylight topology, a rather simple one, visualized in the Yang user interface in Open Daylight's web app. And there's the same topology. Looks a little different because of our layout engine differences, but this is in OpenNMS's semantic topology user interface. Same data, just a different representation. We've also got proof of concept for Open Daylight fault management, where we can essentially ask the controller, hey, is this switch connected or not? We already know about the switch because the switch told us about its inventory via provisioning integration that we did. But if the switch is not connected to the controller, then it's not taking any flows, and we know that there's a problem with that guy. So we can turn something red and create an outage record, create an alarm, kick off a workflow, open a help desk trouble ticket potentially on the back of that information. And then finally, with the ability to have Open Daylight persist time series data into newts, we can pull that out. This is actually pulled out into Grafana because we're lazy. And I didn't want to take the time to make terrible RRD tool style graph definitions for it. It was much easier just to do it with Grafana. But that's Open Daylight data that's stored in an OpenNMS newts cluster. So that's what I got. Love to have you hit me with questions if you got them. Or if you want to get straight to drinking beer, I'm also pro that. I won't be offended. All right, beer it is.
All right. Thanks very much, Jeff.